As we've begun to create LabVIEW programs this semester, we're already accustomed to the two different views, the front panel view as well as the block diagram view. So remember, just as a review, that every time we place an object, such as this numeric control or this one, or a numeric indicator on the front panel, it has a corresponding terminal that's really the exact same thing, except it's in the programming view on the block diagram. Also remember that we started to work with decorations. So decorations such as this one is just in the shape of a triangle that we've added a little bit of description. This is obviously going to calculate the area of a triangle because that's what the description says. And we can place these on the front panel to kind of add a little bit of organization on the front panel and make it look really professional and neat for the user. Also keep in mind that as we place indicators and controls on the front panel, it's really important, especially if we're asking the user to supply data, that we also specify the engineering unit. So for example, we know by the documentation on this front panel that the user will supply height and it'll be in centimeters. The base will also be in centimeters. Then also this gives a little bit of instruction on what is the height versus the base of the triangle, which really should be kind of obvious. So this is what the code looks like, and we're already accustomed to doing very simple mathematical functions and calculations on the block diagram. This terminal is the base, so it's labeled base. This is the front panel control over here. This is the terminal for height, so this is related to this numeric control. The indicator area in centimeters squared, this is related to this indicator in this terminal. And then this is where we do the calculation. So the data flow basically is waiting for numeric information from the base and the height terminal. It'll be multiplied together. Then the result of that data will be sent to another multiplication function, which will be multiplied by a constant of a 0.5. And then the result will be displayed on the front panel indicator. We have different terminals and nodes on the block diagram, and here again this is the same example. So we find these under the numeric in the functions palette on the block diagram, and we just simply pull these over and place them where we want to, and then we created a numeric constant of a 0.5. So these are referred to as nodes. Of course, these are our wires, and then these are our terminals. So hopefully all of that is very familiar to you at this point in the semester. Some of the things that we place on the block diagram, as we're going to find out, we have the ability to go in and change the properties by either right-clicking or double-clicking. When you get down to the function nodes such as this is about as simple as it can get. So there are no configuration related to this other than wiring it up, placing it. There's no resizing it. There's no function other than what it shows that it's going to do on the block diagram based on the emblem. Sub-VIs we'll get into a little later in the semester. If you think about every program that we create, we refer to it as a VI. So right now, think about a sub-VI as just a VI that resides in a VI. So that may not make sense right now, but it will later in the semester. A sub-VI is a function, and it's wired up just like any type of a function node. It just means that it will execute and it'll do what it needs to based on when it receives data or when it's called within the main VI. So it's really sort of like a sub-program in some of the other language related to other programming options. And this is an example of a sub-VI, and this is just a timing function. We have different arrows pointing in and arrows pointing out. So this will allow us to configure it the way we need it to. If I double-click this or right-click and went to properties, I would have other aspects of the sub-VI that I could customize to do exactly what I wanted to do as the program function. We are already accustomed to different wires on the block diagram having different colors. So we are accustomed to orange being our numeric data with a decimal point, blue being our whole numbers, our integers, string also being our data such as text and things like that associated with it. So if we attempt to wire up, in this case, a numeric data type to a string data, we're going to get a broken arrow. We would have to fix that because those two data types are incompatible. And I would have to remove that wire and then wire it up a different way if I wanted my program to work. Some of the wiring tips, if we get a lot of broken wires such as this on a block diagram, remember on the keyboard I can use the function control key and the letter B, and that will receive all of the, delete all of the broken wires in my block diagram. Also, as I begin to wire up, I want to make sure that I try to make the wiring organized and make sure that it's sort of reasonable going from source to source or from input to output or output to input for whatever the case is. So if I finish my block diagram, I can select a wire and select the cleanup wire option, and then LabVIEW will do its best to kind of clean that up a little bit and organize my block diagram for me. But it's really a good practice to kind of keep it organized as I go through. This may be a really great feature for you if this is very difficult to understand the data flow. We have wires running over wires that are not connected. It's just difficult to determine what the program is doing. If I have some code that looks like this and I want to clean it up, I can mouse click over it, and then at the top of the toolbar menu I'll have an icon that looks like this, and that is my cleanup diagram button. If I select that, whatever code that I have selected with my mouse, it will try to organize it, and it does a really good job of organizing it for me. And this example is a whole lot easier to read and to decipher than this example. So use that to your advantage as you continue to create your VIs. We've used the search quite a bit. The search feature is available in the front panel as well as the block diagram. So if I don't know where a certain feature resides on which palette, I can just simply search for it. So the week or so ago, we used the merge signal to put two different data types or two different streams of data on one waveform chart. So for example, if I didn't remember where that resided on my functions palette, I can select search, type in merge, and then I'll get some results. So for example, here, it seems that someone searched for random, and all of these were the results that came up. And if I wanted to use the random number generator, I could just simply pick this up and drag it over to the block diagram. Or if I double clicked it, it would take me to the correct area of the palette on where it resides. So either way, I'll be able to find what it is that I'm looking for. The search palette, we use this quite a bit. This is active in the block diagram view as well as the front panel view. So it will do the same thing. I have different features that I can select. So for example, if I wanted to go in wiring mode, I can select the wiring mode. If I wanted to edit text, I could select this edit text. If I wanted to change data, I could select the hand with the finger to change data. If I wanted to pick up something to move it, I would select the arrow key. If I wanted to change colors, I could go into the color palette here and select the color and then touch a certain area of the front panel or block diagram, and it would change that color. What I would suggest is to, most of the time, just stay in the automatic tool select. So if this green LED is green, if it's turned on, that means that LabVIEW will kind of predict what it is you want to do with the mouse depending on where the mouse is on the block diagram. So 9 times out of 10, you'll probably want to leave it there. And so, for example, if I hover over a block diagram terminal, right on the node input or output, it would automatically go to the wiring mode for me. So that's a kind of a time saver. Typically, it works correctly. LabVIEW is referred to as a data flow type of programming, which means, so for example, if I have two numeric controls on the front panel and I want to supply some data to my program, this addition node will not execute until it receives data on all of the inputs. So for example, there would have to be data here and data here from my control number 2 on the front panel, and then it would execute. The result will be supplied to this function, which is a subtraction function, and it would take that data, subtract a constant of 50, and then finally supply that result to the result indicator. So any function, any node that I have on the block diagram, it will not execute until it receives data at all the inputs. So if we're just looking at an overview of creating a simple VI, keep in mind I have my front panel, all of my objects. Then I have the corresponding block diagram terminals, and then also some of these sub-VIs and different programming functions that's available in my block diagram. So it's really three different things we're going to do. We're going to acquire the data. So the data could be simply me supplying data to the front panel. I could have hardware connected where I'm using the DAC assistant to bring in a signal from a real-world sensor or device or transmitter or whatever it happens to be. I have to have a way of getting data into the program. And then I'm going to do some type of analysis of the data. So it could be a calculation, it could be simply adding some values together, comparing some values. I could be using some of these express VIs that are created and available for me in my LabVIEW block diagram. Once the analysis is done, then I want to present the data. So presenting the data could be as simple as indicator on the front panel, waveform chart, or a Boolean indicator, a numeric indicator, or a string indicator, or I could be sending that data back out using express VIs to write data to spreadsheets. I can be sending a real-world signal to a control device to open and close a solenoid or energize a relay or turning on a warning light or anything like that. If I want to run the program, at this point I'm using the run continuous or either the run. If I have a broken arrow where I normally select the run, that means I have errors in my program that I have to fix before I can run the program. And if I highlight and I mouse click, it will come up with a list of errors, and then I can go in and hopefully find those errors, fix them, and then execute my program. So that is just a continuing review of information that we've already covered this semester so far in EGR 112.